In this video, which is part one of our two-part series on text fundamentals, we're going to look at how text strings work in C# in more detail. So far, we've seen only very straightforward chunks of text embedded in people's programs. We're going to look at how we work with individual characters, how we can combine strings together in interesting ways, and how some of the facts that we learned about how arithmetic is processed in C# influence that. And we're going to talk about strings that contain special characters, right, like foreign language characters or quotation marks or backslashes or that kind of thing. Right? So let's just go into Visual Studio here. And I've prepared a Visual Studio project that has a bunch of different interesting strings in it. And I'm just going to debug into that thing. One interesting feature before I get going into here is Visual Studio has a very flexible user interface. Right? So for example, if I decide I don't want this locals window down here, if I decide I would rather have it be vertical than horizontal, I can just grab it. Right? And then you see how we get these user interface elements that indicate where it can go. I'm just going to dock it over in here. Right? And now I can resize it like that. And so I'm going to have a lot of local variables in this thing. And it's nice to be able to see them all at once. All right, so I'm just going to debug through this thing. The first thing to notice is that so far we've only seen familiar, A through Z, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 characters, the Roman alphabet. Right? C# actually uses a system called Unicode. There's an international consortium called the Unicode Consortium that has been, for many decades now, collecting all of the world's alphabets and standardizing a computer format for essentially all of them. There are a few alphabets that it has deliberately avoided, like Klingon. They are not a big fan of trying to standardize a language that is owned by a corporation. But any sort of natural human language, odds are pretty good that it's in Unicode somewhere. So we can see a few examples here. Right? We have a word in Greek here. This is the word for alphabet in Greek. We've got some Arabic. We've got some Japanese. I don't actually know what these say. I just copied these off of Wikipedia. But you can see C# handles these no problem. It just figures that they are textual strings like any other strings. It handles the accents in them no problem, and so on. Right? One brief note about the locals window over here. You see all of the strings that I haven't assigned yet are marked as null. And we'll talk about what the null reference means in a later video. But basically, this is just saying this thing is a local variable of string type, and there's no sensible value for it to have. It's not even the empty string. It's the null string. We'll talk more about that later. So a string is what? Well, we know that a string is text, but we can more formally say, in C#, a string is a sequence of 0 or more Unicode characters. And if you are interested in the typography and the history of Unicode characters, go to unicode.org. There is a huge amount of information there. It's really fascinating. We saw previously, when we introduced the char type, that characters had their own literal format, but I didn't go into very much detail there. Right? So we know that the string literal, we have the double quotes, and then the text of the string, and then an ending double quote, and that's the literal. Chars use a single quote for their literal format, and this can only be a single character. Right? So if we, I'm going to stop this for a moment. If we try to write a string in here, right, then C# will say, there are too many characters in this character literal. Right? And similarly, if we try to assign a character literal to a string, right, then again we get a red squiggly and it says, cannot implicitly convert type char to string. Right? Oh, you notice also here, this says that the expression that we're pointing at is of type system.char. Something I didn't mention in our episode on types was that all of the types actually have two names. They have their C# name, char or string or something like that. And there is also a corresponding name in the system namespace. That is, in this case, char, right? In the case of strings, it's system.string. In the case of ints, it's system.integer32, and so on. You might wonder where the 32 comes from. It's because the integer takes up 32 bits of memory. Anyway, a little aside there. The point is you cannot assign character literals to strings. You notice also here it says this represents a character as a UTF-16 code unit. If you are interested in the precise definition of UTF-16 code unit, again, go to unicode.org. You will learn more than you ever wanted to about precisely how UTF-16 works, which is the Unicode standardized character encoding that C# uses. All right, so let's fix this so that this is correct code again. All right, so let's continue to step through this. We were here last time. I'm going to put a breakpoint there, just run straight to there. All right. So we have this string. We have this character. We can, as you know, we can change the value of the string. So now it's hello with a capital H. Now, since a string is a sequence of characters, you might think, well, there must be some way to get the characters out of the sequence. And in fact, there is. Right? So this here is called the indexing operator. A string indexer is an expression. It has a bunch of parts. It has a string expression that goes on the left-hand side. It has an integer expression, which goes inside square brackets. And the result of the string indexing expression is it produces the character that is at the offset indicated by that integer in this string. That's a bit complicated, but if we take a look at what's actually going to happen here when we step over this line of code, is my char has become H. Now you notice here it says 72H. The 72 is because every Unicode character has a number associated with it. The number associated with H just happens to be 72. It's letting you know that. All right, the capital letter H is 72. All right, so this has extracted the 0th character. Right? The H is the first character of the string, but I said my string 0. And you might not be surprised if I step here again and I get the first character. It's E, which is the second character. This is pretty weird, and this is often confusing to beginner programmers. What's going on here is there are basically two ways to think about this. Right? One way to think about it is, well, you just add 1, right? I want to get the first character, so I subtract 1 from it. I've got 0, right? I'm asking for the 0th character, so I add 1. I'm actually getting the first character, right? And you just mentally juggle in your head whether you are adding or subtracting 1, depending on which way you're looking at it, right? This is, in my opinion, the confusing and awful way to think about it. The better way to think about it is that this index is an offset. It is how many steps did I take away from the beginning of the string, right? Well, the very beginning character of this string is H. How many steps did I take away from that beginning? None. So I got H. OK, well, here I got E. How many steps did I take away from the beginning of the string? I took 1 step away from the beginning of the string. Right? Some languages have 0-based syntax like this. Some languages have 1-based syntax. There are a lot of fiddly arguments about which one is better. The 0 base seems to be more or less winning. It has some nice mathematical properties. And it's traditional in the C-like family of languages to index things by 0. So however you decide to remember it, whether you decide to just remember, oh, I'm going to remember to always subtract or add 1, or whether you think I'm going to take an offset from the beginning of the string, whichever one makes more sense to you, just go with it. But just understand that this string here has 5 characters, and those characters are indexed by 0, 1, 2, 3, and 4, not 1, 2, 3, 4, and 5. All right. Let's take a look at some examples of more complicated string concatenation than we've seen before. So I have this variable, hello, right? And I'm going to assign a value into it. OK, it's now the string hello. I've got this name, Eric. I've got a number, 1, 2, 3. All right, so what happens when I concatenate hello and this literal, which just contains a space, and my name? Well, it should be pretty clear what happens there. We can hover over this thing. That is hello space Eric. OK, that seems to make sense. We know that what's happening, of course, is C# is parenthesizing this expression. Right? It's saying, well, we have two additions. And so I'm going to parenthesize them starting from the left and moving on to the right. And there you go. All right. So what about this one? This is going to be hello plus number plus number. All right, well, if we step over that thing, then we can see that this thing has become hello 1, 2, 3, 1, 2, 3. All right, exactly as we expect. We know that from our previous video that when you concatenate a number with a string, the number is converted to a string, right? And it looks like this happens 2 times. And so, of course, the same thing is going to happen here, right? We're going to concatenate the number, and wait a minute, hold on. This is 2, 4, 6 hello. What happened here? Well, remember what I just said, right? C# sees 2 additions, and so it parenthesizes them, right, as follows. It pretends that you inserted parentheses here. Now we have number plus number. Number and number are both integers, so it figures you wanted to do integer addition. Right? So it adds the 2 together. It gets 246. And now it says, oh, and you took this integer expression and you added it to this string expression. You must have intended the integer to be converted to a string. This is one of those rare cases where C# sees something that looks potentially iffy and does not give you a warning about it. Right? The way to do this is not actually to insert parentheses here, although that's a fine way to solve the problem. The way that I prefer to solve this problem is to use a method called string.format. Right? We've seen many times, we've seen that there's a method called console.writeLine. And what does console.writeLine do? You give it some values, and it prints them out to the console. OK, well, this is a new method. This is one that we haven't seen before. This one returns a value. Right? Console.writeLine was useful for its side effects, for the fact that it prints something out to the console. This method is useful for its values. Right? So string.format is a method. We call this a static method because it's associated with the type string. There's maybe not a good reason why such methods are called static methods, but they are. And then it takes a bunch of arguments here. So it takes a string literal, right? And we can see that this string literal is in in curly braces, the numbers 0, 1, and 2. Then we're going to give it number, number, and name. Right? So what string.format does is it is a search and replace engine. Right? It says, this is the pattern for the string that I want. Right? Whatever is in 0, replace it with this. Whatever is in 1, replace it with this. Whatever is in 2, replace it with this. Right? So again, we have a situation where something is being indexed based on 0. This is traditionally how it's done in C#. And so if we step over this statement, we can see that in result we have 1, 2, 3, space, 1, 2, 3, space, Eric, right? Which is just what we expected. This thing got replaced with number. This thing is a space. This thing got replaced with number. This is a space. This thing got replaced with name. Right? Now, in C#6, which is the version of C# that is going to ship with Visual Studio 2015, there is actually a much more slick way to do this. And that is just like this. But I caution you, if you're trying to do this in C#5 or any previous version of C#, this is not going to work. Right? This is a feature called string interpolation. So I'm going to call this string variable interpolated. And I'm going to precede the string literal with a $sign. This is a new syntax for C#6. The reason for the $sign is actually another callback to historical tradition. Way back in the early days of not even before Visual Basic, of ordinary Basic, the $sign was used to mean the thing that follows is a string. Right? So this is a little programmer in joke here. So we put a $sign before the string literal. And then anything that is in these curly braces inside the string will be interpreted as an expression. Right? So you can see this is the number, 1, 2, 3, the number, and the name. Right? But what's happening behind the scenes is the C# compiler is actually just transforming it into a call to string.format, right? With the appropriate values here. Right? So if we step over this thing, then we can see that, as we expected, that's the value 1, 2, 3, space, 1, 2, 3, space, Eric. All All right. How do we deal with quotation marks, right? Suppose I wanted a quotation mark in the middle of a string. It seems like that might be tricky to do because a quotation mark is going to end the string literal, right? So there's a bunch of different ways to do that, and I'm going to describe almost all of them, right? So one way is to say I'm going to make a local variable called quote, right? That's of type char. It's a single character. Now, there's no problem with putting a double quotation mark inside a character literal because, of course, character literals don't use double quotation marks. They use single quotation marks, right? So now we have this character, quote. And now we can use string concatenation to concatenate the value of this character into this bunch of strings, right? So I'm going to say Hamlet1 is my variable. It's going to be a quote concatenated with to be or not to be, and then a quote, and then said Hamlet, right? And so if I step over this thing, what have I got? Oh, well, this looks like a mess. Why is this doing this? There's a bunch of backslashes and extra quotes in here, and this seems really confusing. And you can see over here in the local variable window, it's doing the same thing. So what's going on here? Why have we got all of these extra backslashes in here? Well, we'll come back to that in a minute. But what if we actually try to write this thing out to the console? What happens? Well, if we go to our console window, it says, quote, to be or not to be, end quote, said Hamlet. So it seems to have worked, whatever else was going on there. All right, so another way we could do this is we could use the same string.format trick that we just learned about. We could say Hamlet2 is string.format. We could say to be or not to be, said Hamlet, with 0 here and 0 here, and quote. Now, something that you notice about this is before I had 0, 1, and 2, right? And they were replaced by this, this, and this. Here I have 2 zeros, and both of them are replaced by this. And so this is kind of a general purpose string search and replace mechanism. It looks for all of the zeros in curlies and replaces them with whatever is here, right? And we step over this thing. Then we point at it. We can see, again, we've got these weird backslashes. I'm not sure what's going on there, right? But if we actually write it out to the console, we can see, yep, once again, we got the right thing. So apparently it did the right thing. Well, let's examine this more carefully, right? What if we actually took this thing, right, this quote, backslash quote, to be or not to be, backslash quote, said Hamlet, end quote, and just pasted that into the program here, right? Well, we haven't got any red squigglies, and the program is running normally, so something must be going right here. The way that you can put a double quote into a string literal in C# is to precede the double quote by a backslash, right? So this tells the C# compiler, it looks like I'm about to end this string, but in fact I am not, right? Treat this thing as literally a double quotation mark inside this literal string, right? And so if we do this, then once again we see that when this is displayed in the IDE, it displays it as though it were a string literal in the program, right? It does not display it as it would display it on the console, right? I've always thought that's a little bit weird, but that's what Visual Studio does, right? And once again, it's written out the correct thing. All right. There are other things we can do, though. Here is a way that I particularly like to use. We can say backslash u0022, to be or not to be, backslash u0022, said Hamlet. So what's going on here? Well, every Unicode character, as I mentioned before, has a number associated with it. If we write that number in base 16, right, in hexadecimal notation, which I'm not going to go into in detail, but you can easily look up on the internet, then we can, in any string, we can say, in any literal string, we can say backslash u. That means the thing that follows is a Unicode code, right? 0022. 0022 happens to be the code for, you guessed it, double quotation mark, right? So once again, this does the right thing, right? If we print this out, then it's printed out as we expect. All right. What if we want a backslash in the string. We now know that backslash has special meaning. Backslash before a double quotation mark means it's an ordinary double quotation mark. Backslash before U means the thing that follows is a Unicode escape sequence. What if we want to type a backslash, right? What if we, in fact, wanted to type a backslash followed by a U or a backslash followed by a quote, right? Well, as you might have guessed, we use backslash backslash, right? So here we have the Unicode character sequence for the quotation mark, to be and or not to be, with the escape sequence for the backslash. So these things are all called escape sequences. I've used that jargon several times now. An escape sequence allows you to insert special characters into a string literal, right? And they're called escape sequences, again, for historical reasons. It's because if you think about the analyzer as analyzing the text of your program, and it's going along and it's going along, and it thinks, oh, I'm inside a string, then the normal rules, it escapes from the normal rules, and when it hits the backslash, does some special processing for whatever follows it, and then goes back to being the normal rules for processing the inside of a string. Let's keep on going here. There is yet another way to do this in C#. Now you see here, this time I have preceded the string literal not by a $, but by an @ sign. And in here I've got @ double quote, double quote, double quote, to be and or not to be, with the backslash being a single backslash, another doubled double quote, and then a double quote. This is kind of complicated to look at, but it actually makes perfect sense. The @ sign before a string literal means the thing that follows is verbatim the string that I intend it to be until you hit the last quotation mark. If you see two quotation marks in a row, two double quotation marks in a row, treat that as a single double quotation mark. All right, that was probably hard to parse, but if we look at it as the compiler would, we see, OK, it says there's an @ sign followed by a quotation mark. This must be the beginning of a verbatim string. I see a double quotation mark. Does that end the string? No, because there's a double quotation mark after it. So this must be a double quotation. And then everything else is treated perfectly verbatim, right? None of these are escape sequences. This \o is not an escape sequence. The quotes, again, this means do not terminate this verbatim string literal, because there's two in a row. This one terminates the verbatim string literal, right? And if we step over that thing and print it out, then you see we have, yet again, to be and or not to be, said Hamlet. All right. One more. Let's suppose that we have a verbatim string literal, right? So we have this @ here. Then we have the double quote beginning the string literal, and our two double quotes indicating that we want a double quote here. And then at the end here, we just drop off the bottom of the line, right? Pick up over here. We say Unicode sequence \U0022 is a quotation mark. What's going to happen here? Well, when I said that a verbatim string literal is verbatim whatever is in the source code, I absolutely meant that. Spaces, returns, tabs, you name it. If it's in the source code, it goes into the string, right? So this will print out to be and or not to be, said Hamlet. Print out a new line, and then say Unicode escape sequence. This is a quotation mark. So it will not interpret this as an escape sequence. It will interpret it just verbatim in the string. And we can see that if we step over that. And there it is. To be and or not to be, said Hamlet. New line, Unicode sequence, U0022 is a quotation mark. All right. I hope that wasn't too confusing. Once you get a little practice in, you figure out how these things go. So summing all of that up, strings are made out of characters. They're made out of Unicode characters, which is a standard format for almost every human language that's ever been invented. You access the characters in a string with an indexer. The indexer is 0-based, so the first character is character 0. Ordinary string literals can use escape sequences for special characters. You can use string interpolation. So you can have a string that begins with a $sign, and then anything inside curly brackets is treated as an expression that is inserted into the string at that point. And you can have a verbatim string literal. The point of a verbatim string literal is the only thing that you have to escape in a verbatim string literal is the double quotes, and you escape them by doubling the double quotes.